Now let us have the Laplace transform. So the definition of Laplace transform is, if the function of t is defined for all positive values of t, where t is greater than 0, and if s is a real number such that the improper integral f of s is equal to the integral from 0 to infinity of e to the negative st f t dt. So you always have to remember this equation because this is our basis for our computations and for the Laplace transform of every formula that we'll be having. Okay? So let's now have the Laplace transforms of elementary functions first. Example number 1. Example 1. Find the Laplace transform of the function of t is equal to 1. Okay? So by definition, fs or ffs is equal to the integral from 0 to infinity of e to the negative st f or the function of t dt. But what is ft? Ft is 1. So we have the integral from 0 to infinity of e to the negative st of dt, 1 dt. Okay? That is the Laplace transform of 1. Okay? So we now have the integral from 0 to infinity of e to the negative st dt. So what is the integral of e to the negative st dt? We have negative 1 over s of e to the negative st. Okay? That is from 0 to infinity. Okay? Applying the limits, we have negative 1 over s of e to the negative s times the infinity minus negative 1 over s e to the negative s times 0. Okay? So, this thing here approaches to infinity. Meaning, this approaches to 0. Okay? We cannot possibly find the value of this since this is approaching infinity, but it will definitely approach 0. So if that is 0, we'll have negative times negative is 1 over s times e to the 0 that is equal to 1. Therefore, the Laplace transform of the function of t is equal to 1, or the Laplace transform of 1 is equal to 1 over s. Okay? So that is example number 1. How about example number 2? Example number 2. So what is the Laplace transform of the function of t is equal to t? So instead of 1. So the Laplace transform of t is equal to the integral from 0 to infinity again of e to the negative st ft dt. Or this is the integral from 0 to infinity of e to the negative st ft is t dt. Okay? So, this is now in the form of integration by parts. So, what are we going to do with this? If we're going to let u be equal to e to the negative st and dv be equal to t dt, your u is equal to negative du, your du is equal to negative e to the negative st, and your b is t squared over 2. Okay? U dv, the integral of u dv is equal to ub t squared e to the negative st over 2 minus the integral of v, that is t squared over 2 e to the negative st, that becomes positive dt. Okay? So, maging repetitive to. So, might as well change the value of u and dv. Okay? So, try natin yung iba. If we're going to let u be equal to t and your dv be equal to e to the negative st dt, your du must be dt and your v is equal to negative 1 over s e to the negative st. Okay? Apply again the formula. For the integral of u dv, we have uv, that is negative 1 over s e to the negative st times t minus the integral of v du, negative 1 over s e to the negative st dt. Or we have negative 1 over s e to the negative st times t plus 1 over s okay, 1 over s times negative 1 over s e to the negative st. Okay? And we have negative 1 over s e to the negative st times t minus 1 over s squared e to the negative st from 0 to infinity. Okay? Now, next, applying the limits, we have 1 over s e to the negative s infinity times infinity minus 1 over s squared e to the negative s times infinity minus 1 over s e to the negative s times 0 minus 1 over s squared e to the negative s times 0. So this thing approaches to infinity and that approaches to 0. So we have 1 over s e to the negative s times 0 times 0. This thing is 0. So we have negative is positive. 1 negative, positive na nga pala, 1 over s squared e to the 0 is 1. So the Laplace transform of t is 1 over s squared. Check lang natin kung tama. Okay? So that is 1 over s squared. Where s must not be equal to 0. So the Laplace transform of t is equal to 1 over s squared. Okay? Now let us have example number 3. What is the Laplace transform of t raised to n? Number 3. So we have the Laplace transform of t raised to n. Again, we have to use the definition of Laplace transform. The integral from 0 to infinity of e to the negative st, the function of t dt. In here, your ft is t raised to n. From 0 to infinity, e to the negative st times t raised to n dt. Again, by integration by parts. So we have to let u be equal to t raised to n and dv be equal to e to the negative st dt. Your du is equal to n t raised to n minus 1. Okay? dt. And your v is equal to negative 1 over s e to the negative st. Okay? Applying the formula for integration by parts, uv, we have negative 1 over s e to the negative st t raised to n minus the integral of v du, negative 1 over s e to the negative st du is n t raised to n minus 1 dt. Okay? Or we may have this as negative t raised to n e to the negative st all over s plus n over s, the integral of t raised to n minus 1 e to the negative st dt. Okay? And then, if we're going to integrate this once again, integration by parts again. So we have negative t raised to n e to the negative st over s plus n over s, the integral of this. So again, your u is t raised to n minus 1. Your dv is e to the negative st dt. Your du is n minus 1 t raised to n minus 2 dt. And your v is negative 1 over s e to the negative st. Apply again the formula for integration by parts. We have negative t raised to n minus 1 e to the negative st over s minus the integral of v, so this becomes positive, e n minus 1 t raised to n minus 2 times 1 over s e to the negative st dt. Simplifying this, we have negative t raised to n e to the negative st over s plus n over s times negative t raised to n minus 1 e to the negative st all over s plus n minus 1 over s, the integral of t raised to n minus 2 e to the negative st dt. Okay? So what are we going to do here? So, negative t raised to n e to the negative st over s plus n, this must be negative n times t raised to n minus 1 e to the negative st all over s square, okay, plus n times n minus 1 over s square, okay, the integral of t raised to n minus 2 e to the negative st dt. Now, if we're going to apply infinity here, so hindi mo natin po-process muna ha, for a while. If we're going to process this, so this whole thing becomes 0 and this whole thing becomes 0 for both the value of infinity and 0. Kasi magiging 0 to. Yung t natin dito, 0 din yan, mababalo wala. So we were left with this part of the equation here. Now, if we're going to process this once again, this will just continue as n times n minus 1 over s square, the Laplace transform of t raised to n minus 2. Okay? Or we may have this as, in general, generalize natin, the Laplace transform of t raised to n is equal to n times n minus 1 times n minus 2, okay? And so on, up to 2 times 1, all over s raised to n. And the Laplace transform of t raised to 0, which is actually t raised to 0, or the Laplace transform of 1 is 1 over s. So the equation for number 3, or this may be equivalent to the Laplace transform of t raised to n is equal to n minus 1, n minus 2, up to 2 and 1. Okay? If your n is 10, this is 9, 8, 7, 6, 5, 4, 3, 2, 1, and that is actually n factorial. All over s raised to n. But if you're going to continue processing this, iterating this, you will have to have n plus 1. Okay? How did it happen? Okay. For t raised to n, you have 1 over s. And then, for n minus 1, you have s squared. For n times n minus 1 times n minus 2, you have x cubed. Okay? So, yung defining factor natin dito ay yung subtrahend or subtractor natin doon sa n. So, in general, the formula for the Laplace transform of t raised to n is equal to n factorial all over s raised to n plus 1. Okay? Next. Number 4. The Laplace transform of e at. Again, this is the integral of e to the negative st times e to the at dt. Or we could have this as from 0 to infinity once again. Or we can have this as the integral from 0 to infinity of e raised to negative s minus a t dt. Okay? Integrating this, we have negative 1 over s minus a e to the negative s minus a t. But dito ko sa baba ibigay t. Applying the limit from 0 to infinity. Okay? So we have negative 1 over s minus a e to the negative s minus a infinity minus negative 1 over s minus a e to the negative s minus a times 0. Again, this approaches to 0, and we have 1 over s minus a e to the 0 is 1. So what is now the equation? The Laplace transform of e raised to at, is equal to 1 over s minus a, where s is greater than a.